Hello all. So the last class we have studied on one non-parametric measures of association, which was Spearman's rank correlation, and we have done 3 or 4 examples both manually as well as using R software. Now one more measures of association, of course non-parametric measures of association, will be going to learn in this class, and that's Kendall-Stowe correlation. Now, as I have already given you the idea that non-parametric measures of association does not depend on the distribution of the data points, rather it uses the pattern of the data points. So in Kendall-Stowe distribution or Kendall's rank correlation, we are going to use that interrelationship between x and y. What is x and what is y? X is in a paired observation, x is the first recorded part and y is the second recorded part. So in Kendall-Stowe also we are going to fathom out the interrelationship between x and y over say n number of paired observations. So let's start this lecture. As I already told you, we are going to cover Kendall's rank correlation. We will solve a few problems manually and we will solve few problems with using R. Also, we will make a test of hypothesis using R. Now, what is Kendall's rank correlation? Kendall's rank correlation, generally it is denoted as Kendall's tau or Kendall's T in the sample version. Another rank-based correlation coefficient, Kendall's tau or Kendall's T, sometimes we say like that as well, relies on the concept of concordant and discordant pairs. Now, what is the meaning of concordant? Concordant means matching and discordant means mismatching. Okay. So, suppose you have two pairs x1, y1 and x2, y2. You can see here x1, y1 and x2, y2. So, and y1 greater than y2 or x1 less than x2 and y1 less than y2. On the contrary, discordant pairs is a pair of observation x1, y1 and x2, y2 that follows the property x1 greater than x2 and y1 less than y2 or x1 less than x2 and y1 greater than y2. So, what we can see in the concordant pairs, the inequality remains the same, while in the discordant pairs, the inequality remains the reverse. So, let us have one example, because doing that example, that concept of concordance and discordant will be clearer. Suppose your x1 and y1 is 25 and 14. Okay. So, the value of x1 is 25, the value of y1 is 14 and your x2, y2, this is another pair and that is 8 and 12. Now, what you can see that x1 is bigger than x2. Can you see? x1 is bigger than x2 because x1 is 25 and x2 is 8 and y1 is 14 and it is also bigger than 12, y1 bigger than y2. So, in this case, we will say that x1, y1 and x2, y2, these two are concordant pairs. Now, think about another example. x1, y1 is say 25, 14, but x2 and y2, that is 8 and let's say y2 is 2. So, what you can see, x1 bigger than x2, 25 is bigger than 8 But what you can see here, y1 is 14 and 14 is bigger than 2. That means this is another concordant pairs. In case we are changing y2 by say 20, then you will see the reverse inequality. x1 bigger than x2, but y1 is smaller than y2. y1 initially was 14 and y2 for the second observation is 20. So the inequality is reverse. So in that case we will say x1 y1 and x2 y2, these two pairs are discordant. The pair for which x1 is equal to x2 or y1 is equal to y2, we will assign that pair that no concordant or discordant pair appear. The score will be 0 in this case. So for the concordant pair, generally we assign +1, and for the discordant pair, generally we assign -1. The entire Kendall's rank correlation depends on these type of assignments, +1, -1 or trivially 0. If there are n such bivariate observation, total comparison will be for n into n minus 1 by 2. N observations are there. Suppose x1 and y1, x2 and y2, x say n and yn. So how many times you have to make the comparison? You have to check like that, x1 greater than x2. Okay, does it imply y1 greater than y2 or y1 less than y2? Then think about the pair x1 y1, x3 y3, then x4 y4, then xn yn. So for every pair we are making the decision, well, x1 is bigger than x3. Does it imply y1 bigger than y3? x1 is bigger than xn. Does it imply y1 is bigger than yn? So altogether there are n observation, and for each of the observation you are making n minus 1 comparison, right? So a total comparison will be n into n minus 1. But when you are checking x1 and x2, doesn't it hold for x2 and x1? So basically x1 x2 comparison is communicative to x2 x1. So that's why comparison between x1 x2 is synonymous with comparison between x2 x1. So that's why you have to make these total amount of comparison n into n minus 1 divided by 2. Clear? So Kendall's T or Kendall's tau, T is the sample version and tau is the population version. So whenever we are indicating population Kendall's T, we will use this word tau, and whenever we are indicating sample Kendall rank correlation, then we may say Kendall's T. Clear? So Kendall's T, the definition of Kendall's T is number of concordant pairs minus number of discordant pairs divided by n into n minus 1 by 2. So this is the total number of comparison. Now out of this total number of comparison, how many pairs are showing concordance and how many pairs are showing discordant? The difference between concordant pairs and the discordant pairs is the numerator of Kendall's T. And you have to remember, like Spearman rank correlation, Kendall's T measure monotonic relationship, okay, monotonic relationship. And the range of Kendall's T or Kendall's tau is from -1 to +1. T is equal to 1 implies perfect positive monotonic relationship. T is equal to -1 implies perfect negative monotonic relationship, while T is equal to 0 implies no association. Clear? Now let us have the same example or same exercise which we have done in the context of Spearman rank correlation. It's a very interesting example. Two judges rank a number of competitors in a certain art competition as follows. 1, 2, 3, 4, 5, 6. So there are 12 number of competitors. That's what we can see. And Judge A, he has assigned some rank as per their performance, and Judge B, he too has ranked these 12 competitors. Now the question is, measure the Kendall's correlation coefficient and interpret your result. Okay, so first, how many ranks, how many pairs you need to compare? You can see there are 12 competitors. So total number of pairs will be 12 into 12 minus 1 divided by 2. Okay, see here I have written 12 into 11, which is 12 minus 1 divided by 2. And as I told you earlier, that for concordant pairs we are assigning +1, and for discordant pair we are assigning -1. Let's do the problem. So for doing this problem, one can do arbitrary comparison. Okay, so let me get back to this example once again. So you can just make a check. Well, this is your x1 and this is your y1, this is your x2, this is your y2. So what you can do that, well, x1 is less than y1. Does it imply x1 and x2? x1 is less than x2. Is it less than? No, 5 is greater than. So what I can do? x1 bigger than x2. Does it imply y1 also bigger than y2? Yes, y1 is 10 and y2 is 5, and 1 and 5, this is greater than, this is also greater than. We can say these two pairs are concordant. So for concordant pairs we are assigning +1. Similarly, you can make a check with 5, 10 and 4, 1. You can make a check with 5, 10, 2, 2. Now 2, 2, these two rankings are same. So you can just give equal to 0. Already we have seen. So arbitrary comparison can be possible, but one shortcut toolkit we are going to use. What is that shortcut toolkit? That let us arrange the first observation rank in ascending order, and the second ranks will be coming as there. So let us do that. Judge A. So what we are doing? Arrange the rank of Judge A in ascending order and write the corresponding rank by Judge B. What is the benefit? What is the convenience when we are doing like that? When we are doing like that, since your ranks are coming in natural order, there is no time waste for checking for x1. Clear? Only you have to check the y figures. So let us do that. It will be more understandable if I write that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. So 12 observation. And Judge B, corresponding 1, what was the rank given by Judge B? Let us have a quick recapitulation. Corresponding 1, Judge B has given 5. So write it out. 5, 2, 4, 1, 10, 7, 3, 6, 11, 8, 9 and 12. The last one is 12. Now the score calculation. How to do that score calculation? Okay, as I was saying that when you have arranged the ranks given by Jaje in natural order, you have that clear concept that this observation is always smaller than this. Clear? 2 is always smaller than 3. So there's no point of making the match for the rank given by Jaje. You have to only work with the ranking given by Jaj B. So you will see 2, 1 is less than 2, 5 is less than 2, no. So that is minus 1. 1 is less than 2, 5 is, does it imply 5 is less than 2? No, 5 is bigger than 2. Clear? So that is minus 1. So similarly, 1 is less than 3. I am not looking at this part, just have the work on this part, that 1 is less than 3. Does it mean that 5 is less than 4? No, that 5 is bigger than 4. So again a discordant pair, and we will assign minus 1. So let me write all this score like this: minus 1, and this will be plus 1, this will be plus 1, minus 1, plus 1, plus 1, plus 1, plus 1, and finally plus 1. So what I have done? I have done this comparison, this 2 and 5, 4 and 5, 1 and 5. Let's take this example. 1 is less than 4, 5 is less than 1, no, 5 is bigger than 1. So again a discordant pair. So 1 is less than 5, 5 is less than 10, yes, 5 is less than 10. So this is a discordant pairs, and here you can see that plus 1 comes up. So every time you will have to assign this plus 1, minus 1 jugglery, right? Now for 2, should we go for 2 and 1? No, already we have compared 1 and 2 beforehand. So now we will make the comparison to this side, 2, 3, 2, 4, 2, 5, simultaneous comparison for 2, 4, 2, 1, 2, 10, like this. So basically your score calculation will be reducing, okay, because you are not considering the previous observations, you are always working on the successive observations, right? So therefore let me write plus 1, minus 1, plus 1, plus 1, plus 1, plus 1, plus 1, and plus 1, and plus 1. I might be wrong, means in some calculations, because I am doing it on spot. So you can just make a check. 2 is smaller than 3, 2 is smaller than 4, so plus 1. 2 is smaller than 4, 2 is bigger than 1, so minus 1, similar type of things. So basically for 1 your score will be 3, total score. For 2 your score will come as 8, for 3 your score will be 5, for 4 score will be 8, for 5 score will be minus 3, then 2, then 6, sorry, it will be 5, I think, it will be 5, yeah, it will be 5, and finally you will just make these gaps to be filled by the scores, and finally for 12 it will be 1, okay, not for 12 but for 11. For 12, is there any anything left for comparison? No. 12 always bigger than 11, 12 bigger than 9. So when you are doing 11, then it is finished. For 12, no need of going down. Okay. So this is the scores for individual ranking. So finally, your total score will be just the sum of these observations, and that will be 34. That will be 34, and Kendall's T will be 34 divided by that total number of pairs. So 12 into 1 divided by 2, and after calculation you people can check, it will be 5151. So although I have skipped few calculation here, I hope that you understand the pattern of the calculations. So what is the pattern? Once again, that you have to calculate the score for each ranking, comparing the other pairs. 1 is smaller than 2. Does it imply 5 is smaller than 2? No, this is less than. So if it is less than, then we will be assigning 1. But what you can see, it is bigger than, so -1. Similarly, please try to fill all the gaps which I have left for you, just for your practice and concept building. Okay. Now, let us have one more example. This example also we have done in the context of Spearman rank correlation coefficient. So here X and Y, 78, 125, 88, 138, these are the observations. Now, what is the basic difference of these examples from the previous one? In this example, we can see these are the quantitative variable, right? So what I have taught you last lecture, that you have to make all these quantitative variables to be converted in their corresponding rank. Clear? So afterwards, do the same thing and you will find the answer. But we will use this problem by R. Okay, we will use this problem while doing the R codes. Okay. The third example, 10 randomly chosen male college students are used in an experiment to investigate the claim that physical strength decreases with fatigue. Describe the relationship for the data below using both Spearman correlation and Kendall's correlation. Hence, make a comparison. This problem is a little different. Why it is a little different? Because it straightway asking you for making one test of hypothesis, and that test of hypothesis will be based on this statement that investigate the claim that the physical strength decreases with fatigue. Here also two observations are given, two variables are given, minutes between the resting period and another is pounds lifted per minute. Clear? Now what are these observations? These observations are quantitative. Okay, quantitative. In case we want to use Kendall's tau or Kendall's T rank correlation to gauge the association between these two, then we have to convert these observations into rank, right? These are not given in rank, so you have to make the rank. So which one is the smallest observation for this X and this is say Y? So smallest observation is 2.4. Oh no, smallest observation is 2. Clear? So the rank will be 1. Second smallest is 2.4. So the rank will be 2. Similarly, which one is the smallest observation here? Here 90 is the smallest observation. So the rank will be 1. So basically you need to convert it into the rank and then you can proceed for test. One more point, perhaps you have noticed that this example contains mixed number and integer number. Clear? So for X you will have the mixed number, that means number bearing the decimal point, right? 5.5, 9.6, 4.4 like this. Okay, I think I have made a mistake. This will be rank 1, isn't 0.5. I'm really sorry. This will be 1, this will be 2, and this will be 3. Yeah, you see that sometimes it is extremely confusing, okay, unless you are mindful. Okay, so and there is one more point, the presence of outliers. You can see that 90 is as compared with the other observations, 90, this observation is quite extreme, so we can tag it as outliers. Okay, which variable is the causal variable? X and Y, causal variable. You can check out the causal variable from this language, decrease with fatigue. So causal variable will be that minutes, and decrease causal variable will be minutes between rest periods, and the effect variable will be pounds lifted per minute. Okay. Now, what will be the construction of the test? The null hypothesis will be H naught, tau is equal to 0. What is tau? Tau is the population Kendall's tau, and the alternative hypothesis is tau less than 0. Okay. Why less than? Look at the verb decrease. So, decrease means whether it is reducing, whether the association is reducing. So, tau less than 0. Similarly, you can make the same test using Spearman rank correlation. Rho is equal to 0 against H1, rho less than 0. Let us use RStudio for doing these couple of problems. This is third example and the second example. We are here with the third example. Have you seen that the third example is x3, the second example. First we will do the second example, the second problem. I have already written x1 as C78, 88, 98, 69, 59, 80, 60. So, this is just the first observation stack, and the second observation stack or the second variable stack is 125, 138, 156. So, let me run it. Okay, so let me run it. Now, correlation x1, y1, do not forget to write method is Kendall's. So, Kendall, because earlier we have done the same problem using the Spearman, right? So, here we are going to use Kendall. So, Kendall's. Now, you will find the Kendall's correlation is 0.1428. Now, what will be your take on? It is a positive correlation, of course. So, you can say that x1 and y1, x1 and y1, let me write here the conclusion, x1 and y1 share positive correlation, positive monotonic association, but that association is poor, that is poor. So, this what is the degree of association? Degree of association is poor. Why it is poor? See, generally what we do, if the association is bigger than 0.7, then we call it a strong association. Okay, just make a note of this fact. I think I haven't mentioned it. This is kind of a thumb rule. If your association is bigger than 0.7, then we say that the association, or if the value of the Kendall's tau is bigger than 0.7, then we say that this value will give you the idea of strong association. Clear? and if it is from 0.4 to 0.7, then it is called moderate association, and if it is below 0.4 or sometimes below 0.35 like that, then we will tag it as poor association. Clear? Now, according to the sign of the Kendall's tau, if it is positive, then we will say positive poor association, positive moderate association, positive strong association. Okay, strong means bigger than 0.7. Okay, so this is example 2. Now, for example 2, you may be interested in making the test of significance. So, have you checked it out? T is 12, p value is, we are very much interested in p value, 0.7726. So, which is less than alpha. If you fix your alpha as 0.05, so p value, okay, let me write here, let me use this space, p value is less than level of significance alpha. If you fix your alpha at 0.05, do you believe that this p value is less than alpha? No, it is bigger than alpha. If it is less than alpha, then H naught is rejected. Okay, H naught is rejected. But here in this case, we can see that p value is bigger than alpha, so H naught is accepted. So, what is H naught? That true tau is equal to 0. So, H naught generally we write like that. So, what we can write? See, tau is equal to 0. Okay, that means, what does it mean? It means the population measure of association, population measure of association is 0. Okay, there is no association. In other words, you can write there is no association. So, let us get back to R again. Okay. So, for this alternative we have chosen two-sided. So, you can similarly you can write greater or less alternative, and you will find the p value. Okay. Now, let us do the third problem. That, okay, just to incite your interest, let me do one quick trick. So, these are the two variables x3 and y3 correspond to the third problems, and by graphical interpretation also one can have some idea whether they are really sharing any association, right? So, let me run this. Can you see this plot here? So, here you will see the plots clearly showing some monotonicity, but that monotonicity is downward. That means as your minutes between resting period is increasing, your pounds lifted, that effect variable is decreasing out. Okay. So, yes, there is certain case of monotonicity existed here. So, you can also check the monotonicity, you can also check the association between two variables just by drawing, just by having the plot as well. Now, let us have that correlation method. We are going to use, say, Kendall's tau, Kendall's, okay, and make the round. Alternative, have a very minute mind to write the alternative, because we have checked that alternative is tau less than 0, okay. So, run. Have you checked? The tau is minus 0.911, which is quite strong, the strong negative association, and look at the p value. The p value is extremely small, which is way smaller than your fixed alpha. level of significance. If you have fixed your alpha at 0.05, then p-value is very small. E to the power minus 5, what does it mean? That means 1.488 into 10 to the power minus 5. Clear? So very, very small. So smaller the p-value, stronger evidence against H0. So H0 is rejected. H0 is rejected means what will be our conclusion? Let's get back to the PowerPoint presentation. What was your question? Your question was, what will be the null and this thing? Okay, this is example 4 and we were doing example 3. So physical strength decreases with fatigue. Your alternative hypothesis is yes, physical strength decreases with fatigue. So your conclusion will be, there is stronger evidence that physical strength decreases with fatigue. That will be your final answer. Is clear? Similarly, you can have one more example, example 4. A board of marketing, very realistic example, a board of marketing executives ranked 10 similar products and an independent group of male consumers also ranked the products. To describe the association between rankings, find a suitable rank correlation. So you people are quite aware that what type of rank correlation you can do. You can make use of Kendall's rank correlation, you can make use of Spearman rank correlation, it's up to you. Now let us have that second part of this problem. What will be the null and alternative hypothesis for this problem? Now finding alternative hypothesis is really a glitch. Why? You have to read the question again and again just to fathom out what actually your question asks. So in this case, if Kendall's rank correlation, population Kendall's rank correlation is tau, then your null hypothesis will be tau is equal to 0 and the alternative hypothesis will be tau greater than 0. Why greater than? Greater than means positive association, greater than means agreement, greater than means concordant. So whatever the rank for the product made by the executive, if it matches with the rank made by the consumers, they are the manufacturer and they are the consumers. So if consumers and the executives are in line with their ranking, then that will be a better situation, that will be a good situation. So that's why tau greater than 0. Now what is the speciality of this type of example? In this example, you have to have some intuitive guess that what actually the real life story, what actually the pragmatism asks. If the production as well as the consumers are giving the same way ranking, then that will be a better situation. And this thought will be coming from your pragmatism, will be coming from your real life intuition, isn't so? So tau greater than 0. Now rest you can do on your own. Okay. So sometimes you might be in a thought that which rank correlation coefficient is more usable or more beneficial, Spearman and Kendall. Here I am giving you some tidbits, some thumbnails that when you will use what type of rank correlation. For smaller sample size, Kendall's rank correlation gives more accuracy. Suppose your sample is very small, in less than 10, then it is recommended to use Kendall's rank. Spearman rank correlation tends to yield larger values than Kendall's correlation. This fact you can check with any example which we have done. Take one example and for the same example try to find out Kendall's tau and Spearman rank correlation just by using the code method quote unquote Spearman or method quote unquote Kendall. You will yourself find that most of the time Spearman rank correlation is larger than the Kendall's tau for the same example. Okay. So for data having more number of ties, Kendall's correlation is better. So in case you have repeated observation, then Kendall's correlation will be better to use. And Spearman rank correlation is less sensitive to outliers. That means in case you have extreme observation, in case you have dirty observations, the last lecture probably I have used this word, dirty observation means outlying observations, then just to give it a decent touch, you can use Spearman rank correlation because it is less sensitive. And I will ask you to take all the previous examples, construct the test of correlation and compare the p-values. Which one will give you, either Spearman or Kendall, which one will give you better p-value? Better in the sense which rank correlation is giving you the p-value indicating towards the acceptance of null hypothesis or indicating towards the rejection of the null hypothesis. What is null hypothesis? Once again a quick reminder, null hypothesis means that there is no association. Kendall's tau is equal to 0 or Spearman rank correlation, population Spearman rank correlation is equal to 0. So null means no association. An alternative hypothesis may be made as per your question. It might be like tau greater than 0, tau less than 0, Kendall's tau is greater than 0, Kendall's tau less than 0 or Kendall's tau not equal to 0. So I will request all of you to make one example fixed and for that example try to construct test of correlation with Spearman rank correlation as well as with population Kendall's tau rank correlation and make a comparison with the corresponding p-values. Thank you.